Welcome to The Explainer. We're all about breaking down the big, complex ideas that are, shaping our world.
So let's just get right into it. When you charge your car, are you really getting what you pay for? I mean, with millions and millions of EVs hitting the roads, the answer to that little question is becoming a huge billion-dollar issue. And look, we're not just talking about a few cents here and there. This is way bigger. This is about building trust, deep, fundamental trust, in a market that is just exploding. It's about making sure things are fair, every single time you plug in your car. I mean, think about it. You pull up to a gas pump, you totally trust that a gallon is a gallon, right? You don't even think twice. Well, shouldn't your EV charger meet that exact same standard? At its heart, this is all a problem of measurement. And let's be real, when money changes hands, that measurement has to be perfect. It's got to be trustworthy. Okay, so who makes the rules? Who's the one writing the rule book to make sure a charger in, say, Tokyo is playing by the same fair rules as one in Toronto? There has to be a global standard, right? Well, that's where this group comes in, the OIML, which stands for the International Organization of Legal Metrology. Yeah, it's a mouthful. But you can just think of them as the world's referees for fair and accurate measurement. And they've created this guide, OIML G22. It's basically the universal blueprint for building trustworthy chargers, or what the pros call EVSEs. And this guide, it covers everything. It starts with the simple stuff, like these all-in-one chargers you might have in your garage. You can see here the power comes in from the wall, it gets all processed inside this one box, and then flows straight to your car. Super simple. But then it also covers the big, complex systems. Those high-speed DC fast charging hubs you see on the highway. This is a whole different beast. You've got power coming in, getting converted in a huge central unit, and then sent out to a bunch of different stations. The rules have to make sure the measurement is accurate across that entire complicated chain. All right, this brings us to maybe the most important part, accuracy. Just how accurate do these things actually have to be? Well, the rulebook gets really, really specific about this. So check this out. They break it down into 3 classes. You've got Class A, B, and C. The most precise is Class C. It can only be off by, get this, 0.5%. That is tight. Then Class B allows for a 1% error, and Class A, 2%. So it gives everyone, from regulators all the way down to you, a really clear yardstick to measure these chargers. Okay, but here's a little detail you need to know about. It's called the minimum measured quantity, or MMQ, and it's kind of like the fine print. Basically, for a charger to guarantee that super high accuracy we just talked about, it has to deliver a certain minimum amount of juice. For a big DC fast charger, that's 1 kilowatt hour. So what does that mean for you? Well, if you're just plugging in for a couple of minutes for a tiny top-up, the measurement might not be quite as dead on as its official rating. Right, so a charger can be perfect in a nice, clean lab, but what happens when you stick it out in the real world? With rain and snow and blazing heat for years and years? This is where the rulebook gets, well, it gets brutal. It lays out this whole series of intense durability tests. You can literally think of it as a torture test for chargers, all to make sure they can handle whatever the real world throws at them. First challenge, extreme heat and cold. They test these things to make sure they're still measuring accurately from a bone-chilling minus 40 degrees Celsius all the way up to a scorching hot 55 degrees, or even higher, because your build has to be right no matter if it's a blizzard or a heat wave. Next up, electrical chaos. They have to survive a whole barrage of electrical disturbances. We're talking sudden power surges, voltage drops from the grid, even getting zapped with up to 8,000 volts of static electricity. And through all that, the charger has to just keep on measuring perfectly. And what about magnetic interference? Yep, they test for that too. They blast them with powerful magnetic fields to make absolutely sure that interference from, say, big power lines nearby doesn't mess with the sensitive electronics that are calculating your bill. And finally, challenge 4. They literally get shaken and shocked. These tests are designed to mimic a rough ride on the back of a truck and the whole installation process. The bottom line is, it has to survive the journey and work flawlessly from the moment it's switched on. Okay, so we've got accuracy, we've got durability. Let's bring it all home. How do all these rules actually protect you, the driver, at the end of the day when you're looking at the bill? It all comes down to one word: transparency. The standard says that for any public charging session, you are entitled to see exactly what's going on. You get to see the total energy you received, the price per kilowatt hour, and of course, the total cost. And get this, if the price changes mid-charge, they have to show you a breakdown of that too, with the start and end times for each rate. So you see, these rules make sure that the numbers you see on the screen are the real numbers you're actually paying for. And at the end of the day, this is so much more than just a bunch of technical rules. This is about building that foundation of trust, that consumer confidence. Because without that trust, this whole massive transition to electric vehicles, it just doesn't work.
It really makes you wonder, doesn't it? What other complex, invisible systems of rules and standards are working perfectly in the background just to make sure our modern world runs as smoothly and fairly as it does?